Okay, this is chemistry. We're looking at Unit 9, Stoichiometry. We're going to be spending some time in all of these various objectives. C7a, you're going to name compounds. C7b, you're going to write chemical formulas. C8a, you're going to define and use the concept of the mole. C8b, you're going to use the mole concept to calculate the number of atoms, ions, or molecules. C8c, you're going to calculate percent composition in empirical and molecular formulas. And C8d, use the law of conservation of mass to write and balance chemical equations. C8e, you are going to perform stoichiometric calculations. This is the first one of these I've ever recorded, so I'm a total noob. Please excuse this if it comes out horribly. As soon as Miss Howard gets a chance, I'm sure she will record a better one. Okay, you can go on to your next slide now, pal. There we go. First of all, stoichiometry is the mathematics of chemistry. I want you to think about a chemical equation kind of like a recipe. It tells you what all is going to go into it. It tells you what all you expect to get out of it. The big difference between a chemical equation and a recipe is, well, there's not really a huge difference, honestly. If you just think of it in terms of a recipe and what you're going to get out of it, you look at the ratios of the ingredients going into it to tell how much you do as far as eggs or sugar or flour or milk, and then it also tells you about how many cookies you can expect to get out of it. If you need more cookies, you just double how much sugar or eggs or milk or oil or chocolate chips you put into it, and you can expect a certain amount out, which is a lot like a balanced equation. Those coefficients in a balanced equation show you the relative amounts of each ingredient or reactant and the relative amounts of each product, okay, what you expect to get out of there. Stoichiometry comes from the Greek. I don't speak Greek, so I can't tell you what the stoichio part means. I probably should have looked that up. Of course, metry simply means measurement. Okay? The important thing to keep in mind when you're looking at this is that you are talking about a balanced equation. Okay? If you have an unbalanced equation, it tells you what goes in, it tells you what comes out, but it does not tell you how much of any of that you're going to be expecting. Few things to keep in mind. We've been talking about moles. Don't forget Avogadro's number, that 1 mole of anything equals 6.02 times 10 to the 23rd. Okay, that can be atoms, that could be molecules, it could be tennis balls. If you're looking at 1 mole of a substance that you find on the periodic table, you can find that by looking at the mass on the periodic table. Okay, that's how you get your molar mass, formula mass, molecular mass, depending on what you want to call it there. It's all pretty much the same thing. To go from moles to grams, or moles to particles, or particles to moles, or grams to moles, you're always going to start by writing down what you're given. You're going to draw your grid, and we'll look at some examples of that here in a minute. You're going to choose a conversion factor. For example, 1 mole equals the molar mass of something, or 1 mole equals that many particles of something, and then you're going to set it up to where you can cancel. The unit that you start with is going to end up on the bottom of that conversion factor, and I'll show you that here in just a minute. And then it's very easy. You multiply by what's on top, you divide what's on the bottom. Okay? There's some worksheets that we're going to be looking at in your packet later on, but let's take a look real quick at how to do some of these calculations. First thing you need to be sure is that you write down your chemical equation. If you are given a word equation, you need to write out the formulas for each reactant and product. You need to be sure it's balanced. Again, if it's not balanced, then no matter what numbers you put in there, you're going to get garbage back out. If you are going from the grams of what you have, and there's the bell, you then our first step is going to be to change it into moles. Okay? Always go to moles. Moles are kind of the great bridge that gets you from place to place. You're going to go from the moles that you have to the moles of what you're looking for. You're going to use the ratio from your balanced equation. You're going to look at the coefficient of what you start with and what you end up with to find that. Okay? And then you're going to go from the moles of what you're looking for back into the grams of what you're looking for, again using the formula mass of your unknown substance. Okay, that's a blank slide. Okay, mole-to-mole problems are probably the fastest and easiest ones. It's just a one-step problem. For example, if you look here, you are decomposing aluminum oxide. It wants to know how many moles of O2 you're going to make when you decompose 3.34 moles of aluminum oxide. Okay, here's our equation. Here's your aluminum oxide yielding aluminum metal and oxygen gas. It's not balanced, so the next step we do is to balance it. 1 mole or 1 molecule of that will make 2 moles of this and 3 moles of this. So what you are looking for here, if I can pull up a pen, let's see here. What you are looking for, actually what you're given, is 3.34 moles. Why aren't you writing? There you go. 3.34 moles of aluminum oxide. So you're starting with 3.34 moles of this right here. Okay, that is your known. I'm not going to try and draw all that out. You're trying to find moles of oxygen gas. So this right here is your unknown. That's what you're trying to get to. Okay? Now something you need to look at is the ratio of this reactant to this product, and you look at that coefficient. For every one of these, you end up making 3 of these. So let's apply some common sense here real quick. If I've got 3.34 moles of this substance right here, my answer should be more than what I started with as far as number of moles. It should be 3 times as much. So let's go on to our next slide and let's see what we do here. Okay. Okay, so we set up what we're given on our grid, 3.34 moles of aluminum oxide. Okay. I'm really not entirely sure where that came from. Let's see what comes up next here. See if that makes any sense. Oh, there we go. You put what you're trying to get to, which is moles of O2. You put where you're coming from on the bottom half, which is moles of Al2O3. Now, I'm not sure about this because on the last screen it said, let's go back and take a look at that real quick. Oh, there's a mistake in this equation. Hold on. There should actually be 2 of these. Okay? Because 2 of these is going to give me 6 oxygens on this side. I have 6 oxygens on that side. Now I have to put a 4 on this right here. That wasn't balanced. Never trust anything we tell you. Always question the man. Okay? So it's actually 2 of these to 4 of these to 3 of these. So our ratio is going to be 2 to 3. Now let's go back to that next slide. Okay? So it's actually going to be 3 moles of O2 on top, because that's what we're trying to get to. 2 moles of Al2O3 on the bottom, because that's where we're coming from. Okay? Good to know. So, if you do 3.34 times 3 divided by 2, okay, let me just check and see if the math here worked out right. 3 times 3 is 9 plus 1/3. That's about 10 divided by 2. I don't think that number's correct. I think it should be more in the neighborhood of 5-ish. Okay, 5-ish moles of O2. And I'm not going to work that out. I don't have a calculator. You guys can do the math on that. Okay, let's move on. Okay, let's look at this practice problem here. If we have 3.84 moles of, that looks like ethine, okay, C2H2, how many moles of O2 are needed? Now, if I'm not mistaken, I believe that ethine is also commonly known as acetylene. So if we have any welders in the audience, that's what you've got in your acetylene torch. Okay? Wants to know how many moles of O2 are needed. So, burning it, that's what kind of reaction? Anybody? That's a combustion reaction. So in a combustion reaction, we're taking our burnable gas, we're combining it with oxygen, and the two products we're going to be getting there are carbon dioxide and water. And there they are. Okay, now that's not balanced, so let's balance it real quick. 2 carbons over here, we're going to need 2 carbons over here. Oh, and my lights just went out. So you probably can't see me. That's probably better because I'm not much to look at. So I've got 2 CO2s here, which gives me a total of 1, 2, 3, 4, 5 oxygens on this side. I can't get 5 oxygens on that side, so it looks like I'm going to need to double all this stuff. So let's make that a 2, make that a 4. Oh, this has got to be the worst video ever. I am so sorry, guys. Okay, which is going to give me 4 carbons and 4 carbons. It's going to give me 4 hydrogens. Let's put a 2 here to give me 4 hydrogens there. That gives me 2 oxygens plus the 8 here. So I need a total of 5 O2s for every 2 of these. Let's see if that's what we get. Hey, looky there. Okay, so again, we are given 3.84 moles of C2H2. That's our given. That's our known. Okay? Our unknown, we want to know how many moles of O2, so we are looking for this. So the ratio we're interested in is this 2 to 5. What we want is going to go on top. What we're starting with is going to go on bottom. So let's set it up. There's our given. This 5 and this 2, again, come from our balanced equation. So 3.84 times 5 divided by 2, I'm going to assume that's right because everything else is set up correctly, but you might want to check it yourself. And like I said, I'm not entirely sure that we know what we're talking about around here. Okay, now notice here that your units, because you're dividing moles of C2H2 by moles of C2H2, your units cancel out. So the only unit you're left with is moles of O2, which is what you're trying to get to. Okay, this is a great diagram, and you might want to pause here so you can finish filling this out, but this is a really nice way of mapping out how you're going to get wherever you're trying to get to. Okay, you start with your known on this side. Okay, if you have a known amount of mass, then you are going to go from mass to moles of your known substance, and then from there you can go to the moles of your unknown. You can go to the mass of your unknown, or if you wanted to, you could go to the number of particles of your unknown. Really, pretty much, if you will just mark where you start and where you're trying to get to, you can just follow all of these. If you're trying to get to the moles, you're going to divide. Okay, if you're trying to get away from the moles, you're going to multiply. From here to here, you're going to multiply by that ratio of your coefficients from your balanced equation. Okay? I think you already knew that, but that's a handy thing to know. And I think this brings us to the end of the video, so I hope that's been informative, and we'll see you in class.